What's going on, everyone? So in today's session, let's talk about what a function is, and let's introduce the concept. So if you look at the formal definition of a function, it's defined as a rule that assigns to each element x in a set of D exactly one element called f of x in a set E. Now, if this definition seems a bit abstract, that's totally fine. We're going to break it down into a simpler definition, and we're going to think about a function, right, in terms of a math equation whose final calculated value depends on the value of one or more variables. So let's explore that definition a little bit more, okay? And so whenever you see a function, it will generally show up in this form. So this is interpreted as y is a function of x, is a function of x, okay? And that means that the final value of y is dependent on your input value of x. And so to kind of illustrate this, let's come up with an example, okay? And keep in mind that y is going to be the final value or the output value, right? While x is going to be your input value. And then you'll see what I'm talking about now. So, for example, let's say I give you this function. Y is equal to 2x, or I can write the same thing and just replace y with f of x, right? Because y and f of x in this case are interchangeable, and these two lines represent the same function, okay? And so let's look at it from this form. And all this is saying is that the function in this case is defined as 2 times x, right, is dependent on the value of x, right? And so you see that in here. Let's say I evaluate the function at x is equal to 2, right? And all that means is I can write it like this, f of 2, and these two mean the same thing. All I'm going to do is wherever I see an x in my function, I'm going to replace it with a 2. And so in this case, it's going to be 2 times 2. 2 times 2, and that's going to give me an f evaluated at 2 is equal to 4. Okay? Similarly, if we evaluate the function at x is equal to 3, that's the same thing as writing f of 3, right? These two are still equivalent. And wherever I see x in my function, I'm going to replace it with a 3. So in this case, this is going to be equal to 2 times 3. And so in this case, the function evaluated at x is equal to 3 is equal to 6. Okay. And so why don't you take a second and go ahead and pause this if you'd like to work and give it a try yourself before we go over it together. So let's say now that I'm going to give you the function y is equal to 3x plus 2. Okay, and this can also be written, remember, as f of x, right? Because y is a function of x, its final value depends on the value of x that you input, right? So we can rewrite this as f of x is equal to 3x plus 2, okay? And why don't you evaluate this function, right, at x is equal to 2, just to keep it simple, and do that for x evaluated at 3. So go ahead and pause the video and try to work through it yourself, kind of like we did before. Awesome. So when you were evaluating this function at x is equal to 2, right, similar to what we did over here, the function evaluated at x is equal to 2 can also be written as the function at 2. And all we're going to do is replace x wherever we see it in our original function with 2. So in this case, it's going to be 3 times 2 plus 2. And when we simplify this out, this function evaluated at 2 is going to be 6 plus 2, which is just going to be 8. Right? Now, similarly, when you evaluated the function at x is equal to 3, that's the same thing as writing the function, right, at 3, and same thing. All you do is replace x with 3. So in this case, it's going to be 3 times 3 plus 2. So 3 times 3 plus 2. And so your function at 3 is going to be equal to 9 plus 2, which is 11. So if you got this, you're on the right track. Okay? So now that we did these two, I just quickly want to refer back to the formal definition that we kind of glanced over at the beginning, because using these two, I'm going to explain to you exactly what they meant in this complicated statement, right? Or at least it sounds complicated at first glance. And so let's take the example on the left, okay, for instance. So this was our function, right? This was our function. And we evaluated our function at x is equal to 2 and at x is equal to 3. And so, referring to the formal definition, a rule that assigns each element x, right? From our two examples, we know that x in this case are our input values, right? The values that we evaluate our functions at in a set D. So you can think about this as just a set of x values, and I drew that circle for a reason. That'll come back below. And so you can think of D as a set of all input variables that you could possibly use. So all the other numbers you could have evaluated this function at, like 4, 5, 6, and so on. Okay? And so a rule that assigns to each element x in a set of D exactly one element called f of x. So we know that f of x is going to be our output value, right? Or the ultimate final value, right, of our function evaluated at some x, okay? And so when it says in set E, this can be thought of as the set of all possible output variables or outcomes, right? Possible output values, okay? And I drew this as well. So we'll go over that down here. Okay, so based on the definition above, right, we can think of D as this set, right, this collection of all the possible input values or x values you could have used to evaluate this function, right? And we said that E is going to be the set of all possible output values that you could have gotten when you evaluate at all of those input values. And so what this formal definition is saying is basically, right, and I'll label it. So this is going to be your set of all possible input, right? Input X variables. And E can be thought of as the set of all possible output, right? Your output f of X or Y values, okay? And remember that f of X and Y are equivalent, okay? And so here, based on this example, we evaluated our function at X is equal to 2. So let's just say this arbitrary point, right, represents X is equal to 2. And what it's saying is the point that corresponds to X is equal to 2 is going to map onto the space of all possible output values, right? This is going to correspond to the point where this function, right, is equal to 4. So this is going to be the arbitrary point where the function is ultimately 4. Same thing when we evaluate it at X is equal to 3. So let's say now a different point, let's say this one. This point is going to correspond to an input value of X is equal to 3. And we found that when you evaluate it at 3, the function, right, the value of the function is equal to 6. So this is going to map on to a different point in space E. Let's just say it's here, okay? And this point is going to be the corresponding point where the function is equal to 6, right? And so this is what the formal definition was saying. And so just in case you didn't kind of follow that, let's do that one more time, but for this function over here. Okay, so again, we have our set D that represents all of our possible, right, input X values, right? And you have your set E that represents your set of all your possible output f of X or Y values. Okay, remember f of X and Y are equivalent. You can pick either one. And so in this case, we chose to evaluate this function at X is equal to 2 and X is equal to 3 as well. And so let's say this arbitrary point corresponds to the space where X is equal to 2, okay? This is going to map on to a point in space E, let's just say it's here, where the function is ultimately equal to 8. Right? So the function at this point is equal to 8. And let's just say for the function evaluated at X is equal to 3, right? So let's say this point corresponds to X is being equal to 3. And this is going to map onto a different point. Let's say it's here arbitrarily, right? And this point is going to represent where the function is ultimately equal to 11. Okay, so this is what that formal definition is trying to say. Okay? And so let's go from evaluating these functions and let's try to plot some of these. Okay, so let's go from working with functions to plotting functions, okay? And so when you're plotting functions, the basic thing you just need to know is, right, and I'll write what we're doing. We're looking at plotting, right, functions. And just because we're starting off, I'll write f of X here just to kind of build up that recall, right? And so in order to plot functions, we just need to understand the basics of a Cartesian coordinate system, right? A 2D Cartesian coordinate system. So Cartesian, or an X, Y, right, coordinate system. And we'll cover that really quick in case some people have forgot or they're not aware of it yet. So when we talk about Cartesian coordinates, right, in terms of just x and y, the plot looks like this. So you have your x-axis, which is horizontal, and then you have your y, right, or your f of x, right? They're the same thing. You have your vertical axis. And actually, let me create a different one just to show you that they are equivalent. So this plot, or these axes, are equivalent to these axes, right? Same thing, because y is a function of x, right? Does this look familiar? And so let's say, just for quick practice, I wanted to plot, right, this point A, that I'm going to call A, and let's say it has coordinates 2, 3. And so remember that in Cartesian coordinates, the way you read these, the first number is going to be your x coordinate. The second number is going to be your y coordinate. So in this case, x is equal to 2. You're going to move 1, 2, right, to the right, and then you're going to move up 3. So 1, 2, 3. 1, 2, 3. So you're going to move to the right twice, and you're going to move up 3 times. 1, 2, 3. And your point's going to be here. Okay? Now let's say I pick another point. Let's say I choose another point called B, and the coordinates for B are 3, 5, right? Same thing. The 3 is your x coordinate. The 5 is your y coordinate. So on the same plot, right? And let's label this point A so we can discern the two. To plot point B, we're going to go to the right 3 times. From there, we're going to go up 5 times. So 1, 2, 3. And then we need 5 here. So 3, 5 is going to be 1, 2, 3. And you're going to go up 5. And then you can connect these two, right? Connect A and B with a line. And that's your line segment going from A to B. Okay? If you understand this, then let's get into using this type of plotting to look at our functions. Okay? And so let me clear this out, and I'll leave that side. And let's just separate our board out, and we're going to work over here. Okay? And so now let's say I give you this function. I'm going to give you this function. F of x is equal to x plus 3. Okay? Remember, when you see a function given to you like this, f of x can be written as y, right? And the rest of that can just be copied down. So again, these two are equivalent. The reason why I wanted to switch f of x to y, right, is because when you have your function in this form, you can use this neat little table to create your coordinate points, right, that you're going to use to plot. And so let's say I want to plot this function on the interval, right, from x is equal to -3 to x is equal to +3, right? And so I want to plot all the points from x is equal to -3, -2, -1, and so on, all the way to +3, right? Now that I know where or what values I'm going to evaluate, right, this function at. So similar to what we did before, all you're going to do is wherever you see x in your function here, or wherever you see x here, right? Same thing. You're just going to plug in each of these numbers, and you're going to figure out what y value you get out of that function, okay? So let's start with -3. So when you plug in -3 for x, so -3 plus 3, y is going to be 0, right? When you plug in -2, -2 plus 3 is going to be 1. -1 plus 3 is going to be 2. 0 plus 3 is going to be 3. 1 plus 3 is going to be 4. 2 plus 3, right, is going to be 5. And 3 plus 3 is going to be 6. So now this table is going to represent the coordinates that you can use to plot your function. Coordinates to plot your functions. Okay? And just in case you guys don't recognize this, right? This is the same thing as -3, 0, right? Because coordinate systems are always x, comma, y. This next one down is going to be -2, 1, and so on and so forth all the way down, okay? And so let's plot all these points onto our axes to see what this looks like, okay? And so let's create more axes. So again, horizontal axes represent your x, vertical axes represents your y or your f of x, right? And now I'll write this up here in case some people like one more than the other. And so -3, 0. So 1, 2, 3. -3, 0. Right? So -1, 2, -3. -2, 1. So -2, left, 2, up, 1. -1, 2. -1, and go up 2. 1, 2. 0, 3. 0, 3. So here. 1, 4. So 1, 1, 2, 3, 4. It's going to be up here. Right. 2, 5. 2, 5. And then 3, 6. Right. So 1, 2, 3, 6. All right. So now, just like you did before, if you connect all these dots, this is going to be your curve, right, for your function x plus 3. Okay, actually, let me write it on one line so it's a bit cleaner. So x plus 3, right, on the interval from x is equal to -3 all the way to x is equal to +3. Okay, and so this is how you go from your function, right, given the interval that you need to evaluate it on. You're going to form this coordinate table, okay? And then from the coordinate table, now you get all the points that you need to plot, okay? And so here are a couple of examples that you can try, actually. So here's an example, and take a second and pause the video if you'd like to work on it on your own before going over it together, right? And so here, I'll give you this function, f of x is equal to x squared, right? And so evaluate this function on the interval from x is equal to -3, right, to x is equal to +3, just to keep things simple, okay? So go ahead and take a second to do this problem. Awesome. So if you were able to do this problem, let's just check back and see if we're all on the same page, okay? So just like we did up here, right? We were given the function x squared. What we can do is, to set up before we do our coordinate table, we can swap out the f of x for y and copy the rest, and then remember that these two are equivalent, right? Because y is a function of x. And so using this form, right, we can make a coordinate table, x, y. And what are we going to use for our x values, right? We said we were going to evaluate the interval from x is equal to -3 to x is equal to +3. So you're going to evaluate this at all of these values, 0, 1, 2. I think we're going to fit 3. Nice. So again, all you're going to do to fill out this table is you're going to evaluate this function at these x values. So wherever you see x in your function, you're going to replace it, right, with these values. So you can do that here. You can do that down here. Same thing. So -3 squared is 9. -2 squared is 4. -1 squared, 1. And so on, right? 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Okay? From here, these are now our points that we're going to plot. -3, 9. -2, 4. Right? And I'll write out the first one in case it's easier to understand. Right? -3, +9. -2, 4, and so on. Okay, so now let's draw our axes, right? And our axes, same thing. The horizontal is your x, vertical is your y. And so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we need to go up pretty high this time so the numbers are a bit scrunched together. Okay, and so -3, 9. So left 3, -1, -2, -3, 9. Right? -2, 4. -2, 4 is this one. -2, 4. -1, 1. It's going to be here. 0, 0. That's going to be at the origin, right? That's what we call the origin. 1, 1. 1, 1. 2, 4. 2, 4. And then 3, 9. Right? So back up here. So same thing. When you connect all these with a line, hopefully I can get it straight. This is what you're going to get. And these are supposed to be touching, right? So this represents the curve for your function x squared, right? This is very common. It's actually also called a parabola. Okay? And this is what you should have gotten. And if you did, then good job. Okay? And so this is, and so this was going over what a function was, learning how to evaluate them, and learning how to plot them using our XY Cartesian plane. Okay? So if you have any questions, please add it below, and then let me know how it goes, okay?